right-hand side must be 0 always. Suppose another example, a little bit more complicated, in which right-hand side is not 0. You need to manipulate the inequality in order to guarantee that the right-hand side must be 0. This is super important. Okay, no problem. So I focus in the factorization of the polynomial. In this case, when we are using any technique, guys, the classical factorization or the synthetic division. No, but in this case, it's super easy by factorization because I can see the greater common factor is x, no? The x. I factor out. We have x squared plus 2x minus 3 greater than 0. Now, this is trinomial. We factorization trinomial. Entonces, in this case, x, you open two parentheses. The combination is x is 3 and 1, no? 3 and 1, because 3 times 1 is 3, and somehow 3 minus 1 is 2, and this is positive 3 and negative 1. In the last class, we solving this inequality using the combination plus minus, but this is crazy. This is crazy. This is the traditional way. Traditional way is good when you have quadratic, but when you have polynomial degree 3, degree 4, so we have several combinations. So I propose new idea. What is the new idea? Well, the new idea is using one thing is called a critical value. And testing point. Specifically no name for this method, but it's critical value and testing point. And this method is like a combination, algebra and graphic. Okay, let me explain. So temporary, I convert my inequality in equation. And we solve in the equation. This, I know that the original problem is no equation, it's inequality. But this is auxiliary algebra that we need to use it to find one thing is called a critical value. Entonces obvio, in this case already factory. Entonces x is 0, one solution, x equal minus 3, second solution, when you put equal to 0 this, and x equal 1 is, this is my critical value. Let me call CB, critical value. Okay, entonces in this moment, I go back to the graphic part. I do this line that represent all real number. 0 here. Is 1. Is negative 3. Here I am doing partition of the all real number line. Partition using the critical value. So I am doing like that. Look, like you know, partition, like a vertical asymptote, but no, actually it's not vertical asymptote. It's just partition, one here, another partition, and negative 3, another partition. So basically, I have 3 partitions, 1, 2, 3. But when you are doing 3 partitions, we have 4 intervals. So one interval from negative infinity to 3, another interval between negative 3 and 0, another interval between 0 and 1, and another interval between 1 and infinity. Actually, we have 4 intervals. Therefore, we have 4 testing points. And the testing point que I select is totally arbitrary. For example, I select one guy here, totally arbitrary, que represent the behavior in this interval, negative 4. See, another student select negative 5 or negative 20 or negative 200, the answer doesn't change. Another testing point is maybe negative 1 here, and between negative 3 and 0. Here, and between 0 and 1, maybe 1/2. And from 1 to infinity, 2, 3, 4, 5, I select 2. I like to select closest to the critical value. Everyone follow me so far? Okay, so we almost finished. Now, for finding that, you create one table. Look, I want to see this analysis in the test guide. Okay, algebra, graphic table. In the table, I create one column always, gets called a TP. TP is testing point. And the testing point are 0, one column, one row, sorry, -3, another row, and 1, another row. So each row represents the critical value. Sorry. The testing point. Coño. Look, testing. Que 4. The testing are -4, -1, half, and 2. Okay. You put here testing point. Look, TP, testing point, no CB. Hello. Now, I try to evaluate each testing point inside or into the corresponding factor. Actually, we have, let me see how many factors we have in my problem. 1, 2, and 3. So you have x, you have x plus 3, and you have x minus 1. So you put it here in the corresponding column of the table, the factor, and you evaluate. And you attach one more column. Okay, I want to call total. In the total column, I summarize everything. Okay, I need to understand. Okay, this is the typical format for my table. So basically is how many rows, depending the testing point you have. We have 4 testing points. 1, 2, 3, and 4. 4 rows. How many columns? Depending the factor that we have in the polynomial. 1, 2, 3, 1, 2, 3, and 1 extra que is called total. Now this is the most important moment. And you now plugging in substitution. Substitution, -4, where? In this factor. Es obvio que es en -4. Entonces the answer is negative. Y I don't care the value. I care just the sign. Negative. -4 here is, let me try, -4 plus 3. Es obvio que es -1, ¿no? Again, negative. -4 and -1 is -5. It's negative. And we have 3 negative, and the multiplication of 3 negative is obvious que es negative. Yes or no? Negative times negative times negative is equal negative. Si es negative times positive times negative, entonces es positive. So basically, the control of the sign depending of the amount of negative we have in our problem. Si we have even number of negative, like a 2, 4, 6, it's positive. You have odd number, 1, 2, 3, es negative. Si es 5, es negative. Okay, si es 2, es positive. Si es 4, es positive. Si es 3, es negative. You understand the idea? Let's continue. Let's complete fill out.
Oh, one second, Professor. Let me get that right. Hold on. If it's even, it's going to be positive. If it's odd, it's going to be negative, correct?
Absolutely perfect. Even, positive. Odd, negative.
Odd, negative.
And in this.
Okay, thank you.
In this row, we have 1, 2, 3. 3 is odd, negative. Okay, -1. -1 is obvious que es negative. -1 here is positive. You understand que es positive because it's -1. You see, this is important. This is easy. You can do mentally, of course. This is -1 plus 3 is positive too, no? They put the sign. The important information is the sign. The value is totally irrelevant. And -1/2 here is -2, entonces es negative. Entonces we have 1, 2 negative, no? You see 2 negative. Therefore, it's positive. Even. 1/2 positive. 1/2 positive. 1/2 negative. 1 negative is negative. 2 is positive. 2 is positive because 2 plus 3 is 5. 2 minus 1 is positive. We have 3 positive is positive. Okay? So almost I finish. But this is the most important moment because it's the conclusion, no? You need to interpretation, the thinking we are doing now. The thing we are doing now is, look, let me using blue color. Okay. I come back to my inequality. And my inequality is one polynomial greater than 0. And greater than 0, something, that any expression greater than 0, the interpretation is that this expression, any, is positive. Because to be greater than 0 is synonymous to say it's positive, no? And si es less than 0, is negative. That is important. In the right hand side, always we have 0 to compare. So the true statement of this inequality is when the expression is positive. An expression is positive. Here,
you have 2 positives and 1 negative, so
no, 2 positive and 2 negative.
negative.
The first, so I focus it.
So there's only 2 possibilities.
2 possibilities.
There's only 2, which is -1 or 2.
-1 and 2. You are right. You are right. You are right. You are right. And the rest, no important. No solution. No solution. No solution. You delete that part. So through this, okay. Entonces definitely I highlight the solution. Let me using this highlight pen. Is when it's 1, que es this interval. And 2, que es this interval. Of course, 2, this is the confusing part for some students. I don't know why. The 2 was one randomly number que I select inside the interval. Pero suppose que another student select 3, select 4. The problem is que interval start in 1 because 1 is the critical value que indicate the boundary que separate this interval to this interval. So basically, is from 1 to infinity and from -3 to 0. But the last part, include the endpoint or no? Include the endpoint in each interval or no? No. Why no? Because my inequality is just a strict inequality. Suppose que es equal here, equal. Oh, no. Entonces no. Entonces yes. When it's equal, include the critical value, but in this case no. Entonces, the symbolic way to indicate this idea, you put the parenthesis, you put the parenthesis, you put the parenthesis. Entonces, my final answer is then out. My final answer is then. Final answer is parenthesis, -3, 0, union, because we have 2 pieces. You connect them by union, 1, infinity. This is the final answer. Okay, neat.
I can't. Oh, there you are. I can't. Let's see it.
Say again. Say again, miss. You what? You cannot see?
See where you are writing.
Okay.
I can see it now. Thank you.
You got me. You let me know. So you make a zoom. This is the beauty of this board. We can make a zoom, change the color, erase everything. Do you understand very well this example? This is long, I know, but this is not the point. The point is not long or short. It's systematic. Okay, entonces what should I do? Well, you manipulate the inequality in order to guarantee that the right hand side must be 0, no? After that, factorization of the polynomial using the technique you know, maybe by factorization regular or scientific division. After you convert the inequality to equation, determine the critical value. The critical value is a good guy can help me to create partition.
I see where you're writing. Maybe it's just.
Say again. I don't hear. What happened with the communication? Normally I hear you very well. You hear me or no? Using the chat. If the microphone something is wrong, using the chat. A ver, what's the problem? I need to understand what's the problem. Who is the lady that speak to me? No, you are no Joyce, no? No, okay. Let's see what happens after. Okay, a board again. Do you see the board? Okay. Okay, I can erase the board to continue with the second example. Yes or no? Yes. Yes. Okay.
Yes, Professor.
Example two now. Example two is very, very interesting. Bring me a new situation. X to the 4th power greater than or equal, or X to the 2nd power. Suppose this is inequality. What is the manipulation? Guys, don't try to create your own way. No, it's the way I explain here. It's the universal way. Okay, what should I do? What should I do? Step number one. Step number one, obviously, is try to create the right-hand side, 0. So I move x to the 4th power minus 4, x to the 2nd power, greater than or equal to 0. This is important, extremely important to start. Why? It's important because in the table, I analyze if it's positive or it's negative. And 0 is important level. Suppose que 0 is the level of the C. Level of C. Entonces, above the C, under the C. But this is super important. In the table, we are using positive or negative. And negative and positive, we respect what? We respect 0. No? Okay, so now factorization. The greater common factor es obvio que in this case is x squared, no? And between x to the 4th power and x to the 2nd power, we have in common 2x. I factor out. Now, I continue factorization because I see a difference of a square. Now, the classical formula of the difference of the square, xx to 2 plus or minus. And this is my inequality. It's equivalent to the original equivalent, but this is very, very confusing, and this is very, very easy using the critical value. You convert temporary to equation, temporary because the solution of this not necessarily is the solution for the inequality. But this helped me to find critical value. The critical value is 0, the critical value is -2, and the critical value is positive. This is the critical value, and the critical value helped me to create the partition of the all real number line. 0, partition. 1, 2, partition. -2, partition. Okay, now in blue color, I select testing point. Actually, we have 1, 2, 3, and 4 intervals. One good testing point is -3, another is -1, another is +1, another is 3, 4, 5. And regardless the testing point that you select, the answer stays the same. TP, table. -3, -1, +1, +3, testing point. Factor involved in my problem. X plus 2, x minus 2. It doesn't matter the order. The order is not important. You copy in either order. I want to keep the order, no? No necessary change. And you condensing the information in one extra column I call total. So I condensing the information. Okay? And you plug it in. Let me use blue color. highlight blue color. Negative 3 is negative. Negative 3 plus 2 is negative 1, negative. Negative 3 minus 2 is negative 5, negative. 3 negative and 3 negative is negative. Okay? And likewise with the other value. No? Negative 1, negative. Negative 1 is positive because it's negative 1 plus 2 is positive 1. And negative 1 minus 2 is minus 3 que es negative. 2 negative is positive. 1 positive. 1 positive. 1 negative. 1 negative is negative. 3 is positive. 3 plus 2 is 5. Positive. 3 minus 2 is 1. Positive. 3 positive, of course, is positive. I come back to my equation. My equation is greater than 0. Again, to be greater than 0 is the positive. That the positive is the true statement. The true. O sea, suppose que dices de, bueno, ese actual es de testing. Okay. Negative 1, pass the test. Positive 3, pass the test. Positive 1, fail the test. Negative 3, fail the test. Okay, therefore, my interval solution is the interval that negative 1 belong here and positive 3 belong. But actually it's in between negative 2 and 0. Wait. Something is wrong here. All right, let me see. Negative 3 is true.
Wouldn't it be positive, Professor? If everything.
Let me check here. Something is wrong because my paper is completely different. Okay, minus 3, negative, and negative. Carajo. I forgot something. Wait, I forgot something, coño. Look, this is a square. Yes or no? Okay, you factorization x squared. I don't understand why I copy x without a square. This is x squared. This is x squared. Yeah, I understand now. Si es x squared, this column is always positive. Because regardless si es negative 3, so negative 3 squared is positive. Negative 1 squared is positive. Everything is positive in this. Okay? Therefore, we have 1 negative, 2 negative, sorry, is positive. Let me erase that part. One, this column, this complete column is positive. The 2 negative, is positive. 1 negative is negative here. Again here negative. This is correct and it's a positive. So the true is this and this. When I highlight, let me highlight using another color. Highlight with the rainbow. Is that part. The part que contain negative 3.
So it'll be between negative 3 and 3. Because it's positive.
Is from negative infinity to negative 2. Remember, okay. Negative 3 was arbitrary, randomly testing point que I select inside. Suppose que another student select negative 4 or negative 5, it's the same behavior. So basically, you understand que negative 3 is like, let me try to put analogy. Suppose que you are in the one country, for example, United States. And you ask one citizen, are you American, yes or no? Maybe yes, maybe no. Pero es the behavior que you suppose to have everyone inside that country, okay? And also, I highlight this part. The rest, no. The rest is, this is a fail and this is a fail. Negative 1 and positive 1, look, is negative, and the negative do not correspond. Ahí. Hey. What the hell? Putting off microphone, please. This never happened with this class. Another class, yes, is a student in elementary, but you're advanced students. Putting off the microphone when you want to speak with me or ask me some question, you activate the microphone, otherwise no. Okay. Now, okay. This now the complicated part. Very complicated part or confusing part. You understand that one solution is this interval. This interval is from negative infinity, comma, negative 2. But I don't know if this is parenthesis or bracket. Parenthesis or bracket. Okay, I again forgot here to write that the original problem is equal. Equal means that this is no strict inequality. This problem is a combination inequality and equation, because it's both together, or equation. It's the proper conjunction. It's both. Therefore, it's obvious que incluye negative 2 because the solution for the equation is this. Belong to the solution of the problem. So this is bracket. This is also bracket. Oh, and 0 also. Hello, professor, me as well. Verify this. Okay, this is another class. Entonces, bracket here, union. We have another interval, but before that, you want to write from left to right, you put 0 like a point, union, bracket, 2, infinity. And this is the final answer. Okay. This is very complicated. The final answer is formed by 3 pieces. The new thing that bring me this example is, okay. The new thing that bring me this example is, okay, let me enumerate. New thing that bring me this example. Number one is that you need to manipulate the inequality in order to express it, the right-hand side equals 0. In the first example, it was given this condition, but not always happen. You need to manipulate. This is the new thing. The second new thing, important. Listen now, is that I can see that when you have one column of the factor that contains exponent even, like a 2, like a 4, this column is always positive. Plus. Entonces, when it's plus, I don't care this column because the control of the total sign depending only of the amount of negative. 2 negative, positive. 1 negative, negative. 1 negative, negative. 2 positive, positive. So this is positive, that's completely irrelevant, and you can delete mentally in your mind here, x squared. And this situation happens when you factorization the polynomial. Suppose we see now one example I bring now. Suppose we have this, and you see degree 2 delete. Okay, and you take only this. And when it's equal, this inequality and this inequality. So you have to delete the factor with even exponent. I explain it in the next example. It says totally delete or partial delete. And number 3, important new thing in this example is that when there's no strict inequality, it's a combination inequality and equation, you have to consider the solution for the equation as belong to the solution for the inequality. Entonces es solution of equation is part of the problem. Okay? Very good, very good, very good. This is detailed. We need to do several examples to understand everything, the big picture of this, but it's okay. I bring two more examples, polynomial, polynomial, polynomial. And you help me now. May I erase the board or no? Come on, come on. What's going on?
Yes, sir.
Yes,
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 sir.
yes. Okay, no problem. Erase the board then. I forgot to record the video. Let me see if I forgot. No, somebody help me. Good, good, good. Somebody help me. Good. Okay, okay. Let's go to the number. It's the number 3, no? Number 3 example. Number 3 example is easy, or relatively easy. It's 4x squared minus 19x minus 5. Greater than or equal to 0. Solving this inequality. Oh, nice. I like that because right hand side is 0. I don't need to do anything in that sense. Now factorization this trinomial. Remember my way to do the factorization, you multiply that number and that number. I don't care the sign. The sign is not important. It's 20. I need to find two numbers that multiply, give me 20. And somehow when you addition or subtraction, give me 19. It's so because 20 and 1, because 20 times 1 is 20, and 20 minus 1 is 19. So I copy 4x squared minus 20x plus 1x minus 5. I copy the trinomial one more time. If you want to put it greater than 0, but this is not important now. And you apply factorization by grouping this and grouping that. The great common factor here is 4x, x minus 5. The great common factor here is 1, x minus 5. And x minus 5, again, is great common factor, 4x plus 1. Okay, and this is the factorization. Let me copy the factorization. X minus 5, 4x plus 1, greater than or equal to 0. This is my new inequality after the factorization. Okay, so let's finding critical value. For finding critical value, temporarily you convert the inequality to equation. Now I can see x minus 5 is 0. Apply the 0 factor property, therefore x is 5. And 4x plus 1 is 0, therefore x is equal minus 1 over 4, no? We move 1 to the right hand side, minus, divided by 4 both sides. And this is my critical value. My critical value is 5 positive and positive 5 positive and negative 1 over 4. Here I represent graphically this idea. This is my all real number line with my all real number line, better, infinity, negative infinity, 0 here, 1, 2, 3, 4, and 5, partition and 5, and 1/4, I suppose this is negative 1, no? 1/4, I suppose this is 1/2, 1/4, negative 1 over 4. Okay, now using my pen, I select, we have two partitions, nice, but we have only 3 testing points. One testing point maybe I like negative 1, Another testing point may be 0 or 1. I like 1. And another testing point is 6. And using this testing point, I create my chart. Testing point. -1. +1. 6. Okay. How many factors we have in my problem? We have only 2, no? Let me come back to the region. How many factors? Dark factors. We have x minus 5, and we have 4x plus 1. And the famous total column. Okay? Here, and here. I'm plugging in. -1 here, -1, negative is -6. Negative. Not necessarily enclosed in the circle. Negative. -1 here is -4. 4 times -1 plus 1. And -4 plus 1 is -3. Negative. And 2 negative is positive. No? 1 is negative again. 1 here is 4 times 1 is 4 plus 1 is positive. Is negative. Because we have only 1 negative. And 6. And 6 is positive 4. So 6 minus 5 is 1, and 6 times 4 is 24, plus 1 is 25. Let's solve it. I come back to the original problem. The original problem again is greater than or equal. Therefore, the true statement is here in the positive. Not always this happens, guys. If the inequality, I change this sign, look. And then in another problem you can see, but not in this problem. Okay, I change this sign. I change not like that, sino less than or equal 0. Entonces es obvio que en this problem, no in our problem, the true statement is the negative part. Okay? Entonces ready. This interval was okay. And this interval was okay. Okay? And my final answer is boom, boom, from negative infinity, comma, 2. Remember, -1 was elementary, randomly guy que I select. But actually, my country, my interval is extending to the -1 over 4. ¿Incluye -1 over 4? Yes or no? ¿Es el bracket o es paréntesis? ¿Es el bracket o es paréntesis?
The bracket.
How do you know?
Because it includes it, but it's equal to, it stays right there.
How do you know que incluye? How do you know que incluye? What is the clue? Que give me information que incluye.
It's greater than or equal to. Right
Exactly.
Here on the sign.
When you see equal, incluye. No equal, do not include. So both bracket. Bracket here, union, bracket 5, comma, infinity. Final answer. Final answer. I have one more polynomial equation. And also, let's do it rational. It's similar, but it's a little bit more interesting and complicated. Okay. Erase the board or not yet?
We're good.
Yes, I can.
Good.
May I? Yes or no? Yes or no?
Yes, sir. Go ahead.
Go ahead. Go ahead. Okay. Suppose number 4 example, no? Example 4. Example is W. Are you going to return back to the campus? No, to the campus. No. My class is always Remotely. Bueno, ese email. After I answer. Okay. Number 4 is W to the 4 power minus 20 W squared plus 64. Less than or equal to 0. This is degree 4. Degree 4. So I suppose that we have 4 solutions. That the solution for the polynomial equation contains 4 solutions. I don't know if everything is complex or real or repeated or not repeated. Okay, entonces, okay, this is basically this is trinomial. This is trinomial. Why not? Let me try factorization for a trinomial. This is W squared. Where come from W squared? W squared is the square root, this guy. And the combination is, let me try 16 and 4. Because 16 times 4 is 64, and 16 plus 4 is 20. Entonces es negativo. Yes or no? This is trinomial factorization. Now I can see, wow, it's 2 different of a square. Then you apply different technique to factorization, no? In this case, W, 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 and W. In this case, 4, 4, plus or minus. This was the factorization of this. And the factorization here is 2, 2, plus or minus. Okay, and this is my new inequality that contains 4 solutions, 4 real zeros. Actually, the real zero is in W equal negative 4, W equal positive 4, W equal negative 2, and W equal positive 2. And we're using this like a critical value. Okay, we have a real number line. We have 4. This is 0 in the middle. 1, 2, 3, 4. 1, 2, 3, 4. Partition, 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 and partition. How many testing points I need to select? How many? How many? How many testing points? How many?
4. 4.
4. Everyone is agree 4? Testing, testing. When you have 4 critical value, actually when you are doing 4 partitions, you get 1, 2, 3, 4, and 5 intervals. Yes or no? And the amount of testing is equal to the amount of the interval. So suppose I select negative 5 here, and that interval gets from negative 4 to negative infinity, the positive infinity. 1 here gets negative 3. 1 here gets 0, good, 0 is good guy. 1 here gets positive 3. And 1 here gets 5 or 6 or 7, whatever. 1, 2, 3, 4, 5 testing. Always the testing point is 1 more than the critical value. If the critical value is 4, the testing is 5. Let's try to organize the table. Guys, are you aware that this method is relatively easy compared with another classical method? Contain one part of algebra, is that part, one part of graph, is that part, and one table. So when you solve this in your test, I need to see everything. Okay? So I copy the factor. The factor is W plus 4. Another factor is W minus 4. Another factor is W plus 2. Another factor is W minus 2. And the last column is the total. And the testing point is -5, -3, 0. 0 is good. So I like 0. The 0 is easy to evaluate, no? More row. 3 and 5. Now substitution. Is it negative? Let me using another color. That color is good. Negative. This is negative. You check it, see I make a mistake or not. This is negative. This is negative. Okay. And what is the total sign, please?
It's gonna be negative as well.
It's negative.
Yes, negative. Negative times
No,
negative times negative.
no. How many negative you have in the multiplication?
4.
Exactly. 4. When you have 4 negative plus.
Oh.
Okay. Listen to me. Negative times negative times negative times negative. You know que negative times negative is positive. Negative times negative is positive. And positive times positive is positive. Wait. Okay. But what is the shortcut? You count. How many negative we have? 1, 2, 3, 4. Even positive. Odd negative. Okay. Let me complete the second row. The second row is positive. Because -3 plus 4 is positive 1, no? But the rest is negative. What is the total sign now? What is the total sign now? What is the total sign now?
Negative.
Negative. Because we have 3 negative. 1, 2, 3. It's odd number of negative. The second is positive.
We'll take it, Professor. We'll take it. Okay. The way I'll read the chart, for example. Let's go to the example, the second one, not -5, but -3. It has positive, negative, negative, negative. It's gonna equal negative. Okay. You said it's even. So whatever
even,
more number has, it's even.
You have even or odd. Okay. Regardless the testing point you select, you get the same combination of the sign. You need to know que si es even negative es positive, and si you have all negative es negative. This is your question or not your question? So don't try to think another problem.
Somewhat.
This problem. We are solving this problem.
I'm not catching. I'm sorry. Forgive me. All right.
No, it's okay. I understand. Could you focus in the question? Come on. The question is in the second row. In the second row. Second row.
Positive times the negative. Okay, I get it. I'll do it differently. I understand how to do
it. But okay, wait. Okay, but what is the shortcut? What is the shortcut to do?
But that's why I was asking about the shortcut. For example,
the shortcut is I don't care the positive. I count how many negative. 1.
Okay, so we're always counting negative.
Exactly.
Okay, and then however many negatives we got, if it's even, if it's positive, perfect. I got it. I got count the negatives.
Yes. Right. The positive totally irrelevant. The positive does not participate in our game. No. Only the negative participate in the game. Okay, 0 is negative. Now it's positive here. It's negative here. Entonces, what is the sign here in the total?
Positive.
Eso.
Positive.
3 is positive. Negative. Positive. Positive. What is the sign here now?
That's odd, so it's negative.
Exactly. And the last one is positive. Positive. Es obvio que es positive. Okay, so I come back to my original problem. Y I can see que dice inequality. Wow. It's less than the true statement. And the last column total is the negative. This is negative guy. True. And this is negative guy. It's true. The interval que pass the test is the interval in which belong to negative 3, belong to negative 3, get this, and belong to the positive 3. Okay. And the rest is no good. It's completely false statement. Now, my next question is, when you rewrite the final answer, you're using square bracket or parenthesis? What do you think? Here, and the endpoint. Square bracket or parenthesis? I write now
square bracket. Square bracket because it's equal to.
Exactly.
It's equal to or.
Exactly. The reason is because it's equal to. You see that symbol? This symbol is the combination less than or equal. This symbol is just less than. This is less than is parenthesis. Okay, so my final answer. My final answer is bracket negative 4, comma negative 2 bracket union. I put union because we have 2 pieces, no? Bracket 2, comma 4. And this is the final. Do you understand very well this or no? It's relatively easy. It's relatively easy. Yeah. Let me try to find one good example of the ration. Let me try. Let me try a ration. I can see the solution. Okay. Mister, this is the answer. You see now? The student can say cannot see the solution. You can see now? Come on. Using the chat. Solution. Final answer, no?
We see it. We're good.
Say again?
Yes, Professor. We see it. It closed up. You zoomed in. We're good.
Okay. But you don't get. Okay. I need to understand what's the problem. Guy, I'm your teacher.
No, sorry. No. I have very bad signal, Professor. So it's
okay.
I have a lot of people on the internet.
Okay. Don't be shy. Any question is my pleasure. I enjoy when a student asks me a question. Of course, smart question, no? The stupid question is, for example, I don't understand anything, because you don't give me some clue to explain, no? What part, what line you don't understand, the second line, the last part. Could you explain with me again? Okay, my pleasure. Okay. Let me come back to the board. Let me see board. Here. You see the board now?
Yes, sir, we do.
Okay. Now we continue doing similar. Well, now we are doing using rational, not polynomial, rational. Let me start for the one elementary example. And after little by little, I complicate your life. Suppose this example we are doing 4. That's a 5, no? A 5. Now, a 5, no?
Yes, it's 5.
A 5. Suppose this, x minus 1 divided by x minus 5. Less than or equal to 0. So far, we are doing polynomial. But this is not polynomial, this is rational. Rational, remember, is division to polynomial. One polynomial divided by the way, this polynomial is degree 1, both. But it's okay. It's degree. The procedure is similar.
Professor, is it safe to say that our answer is going to be negative since it's equal to or greater than 0?
Yeah. We have every possibility. Less than or equal to 0, greater than equal to 0, greater than 0, less than 0. This is the 4 combination that we can find. Specific, this is this. The first one. Okay? That's mean. What is the interpretation is? Interpretation is this problem actually is no one problem. It's 2 problems. You can interpretation in your mind like x minus 1 over x minus 5 less than 0 or or x minus 1 over x minus 5 equals 0. Because this symbol is the combination less than 0 or equal to 0. And you can work separate, you can, but I do not recommend that. No. I do not recommend that. No. This is only to illustrate the meaning of this symbol. But I do not recommend working separately. No. Let's do it exactly in the same way that we are doing in polynomial. But in order to find critical value, you find the critical value of the polynomial in the top, critical value top, critical value bottom is equal to 0. Sorry, x minus 5 equal to 0. Okay, is obviously x equal 1 and x equal 5. So we have two critical values. Is the 0 of the polynomial in the top and the 0 of the polynomial at the bottom. We have two critical values. And we're proceeding exactly the same. We are doing the sketch of the all real number line. We are doing partition using two critical values, that's 1 and 5. Using the critical value 1 and 5, and you select testing point. How many testing? I need to select. How many?
You need to select three. There's two.
Three.
You select 3. Always go 1 over, so you can.
Super. What do you recommend me using? For example, it's up to you.
Inside the value, something like 3. And outside the value, like 0. And 6.
Eso. You select exactly the same I select in my paper, mister. Testing point.
Cool.
0, 3, and 6. And you copy the factor. The factor involved in my problem is x minus 5 in the top. X minus 1, sorry. X minus 5 in the bottom. And the total column always I use to summarize the information in the last. I'm plugging in. It's a negative. Let me use my elegant color, rainbow. Negative, no? And this is negative also, no? Because 0 minus 5, negative 5. No? So the total sign will be positive or negative. Tell me.
Negative odd.
Negative. Positive. Because how many? Because how many negative you have so far? How many? Positive. Why? 2 negative. Even number of negative is positive. 3 is positive. Because 3 minus 1 is 2. 3 minus 5 is negative 2. It's negative. This is negative. And 6 is positive. And positive is positive. Okay? I come back to my original inequality. Remember, the original inequality contains less than or equal. So the negative, guys, the negative value is the true statement. It's the true. Otherwise, false. I don't care this, I don't care this. I care only this interval. And this interval is the interval in which belong to the 3 at this interval. Okay? And what about the endpoint? This is a little bit confusing. You learn in polynomial that when it's equal, you put a bracket. Yes, you are right. But you put the bracket only in the 0 of the numerator. ¿Qué es this? Wow. ¿Qué es this? But in 0 of the denominator, never, because it's undefined. Okay, because this is do not belong to the solution. It's fine. Then the final answer for our inequality is bracket 1, 5, paréntesis. Carajo, paréntesis. Bracket in 1 and parenthesis in 5. Do you understand this part? Okay, because okay, the part, okay. Let me try to understand in another way. Look. Actually, suppose I solve it in that way. When I solve this inequality, I get the interval that I highlight in yellow color. However, when I solve this equation, you know something. When it's a rational equal to zero, it's the top part is equal to zero. I don't care. That part is not important. Therefore, one yes belongs to the solution is the symbolic way to indicate this idea is using the bracket. But never participate in the game because what happened in 5? 105, so you try to plug it in here. 5 minus 5 is 0, and division by 0 is undefined. You know very well, right? Entonces, we have systematic way, but you have always apply intuition and common sense to solve this kind of inequality. I bring, let me see, ay carajo, the time flies with you. Okay, but let me try at least to do 1, 2, 3, and 4 inequality more. That kind gets rational. Okay, example 6. Example 6. I suppose that today we have no time to start review. No. Okay, suppose this. 10 minus 5x divided by x squared less than or equal to 0. Suppose this. This is relatively easy. This is relatively easy. Because I remember something important. I remember that any factor can contain even exponent like that, or another factor, suppose x minus 1 squared, or x minus 2 to the 4th power, is always positive. So I guarantee you 100% that this guy is always positive. Therefore, see, this guy is always positive. The responsibility to be negative is only for the top part. Because I can simplification this inequality, copy only the top part and less than or equal to 0. I ignore, totally delete the exponent, the factor that contain, delete, totally delete. This factor do not participate in the inequality because it's positive. And remember, the control of the inequality have the negative in the table. In the table, I care the negative. I don't care positive. Bueno, I care, but when it's only positive, you know. And so basically, I reduced my original, que look like complicated inequality in one elementary inequality that we solving without table, partition. No. I move 10 to the other side. Look, I move 10 to the other side, divided by -5 both sides. X, and remember, when you divide by a negative number, you have to reverse the sign, and this is 2. And that's it. So you want, if the teacher say you express this answer in interval notation, this interval notation is bracket 2 comma infinity, no? Okay, suppose this is all real number line. This is infinity positive, this is infinity negative, this is 0 in the middle, 1, 2. And this is 2 is to the right because this arrow indicates to the right, and you highlight that part, only that. And include 2 because it's equal. It's the equal indicate right. This representation is exactly the same. Do you understand this idea? This was easy. I want to illustrate this example because we're using not too much algebra, but we're using a strong imagination, no? You immediately you see exponent even, you delete and the inequality. Okay? Let me explain another very interesting. 1 over sample, this is 7. 1 over x minus 2 less than or equal 2 over 3x minus 9. Okay. It's very confusing. Very confusing. This is the typical problem I like to put in the test. Okay. What is the typical mistake? Okay, I saw every student doing, even the tutor sometimes make a mistake. So some people believe it is working similar to equation. Suppose that this equation you apply cross multiplication. No. In inequality, no. In equation, yes. In equation, yes. Here, no. Say again.
You can't do that. They're two separate equations. They're one is equal to or greater than the other, so you can't cross multiply it. You can't do
that. You can't. No cross multiplication. This is a mistake. Remember, what is the most important idea for solving this inequality is no linear. Polynomial or rational. Right-hand side must be 0. Right-hand side must be 0. Don't forget this idea. Right-hand side must be 0. Now you move this. Okay, now right-hand side must be 0. I am happy now. You are doing this. You are doing okay. You start good. This is wrong. Cross multiplication. No. Why no? Because you know, okay, in inequality, when you multiply by negative number, it's reversed. The inequality sign. When you multiply by positive, it stays the same. But I am looking for the interval que satisfy this inequality. I don't know if it's positive or negative. But what sign I put, the same or opposite? No, I have no idea. No. Okay. So you move this guy to the left because I need to guarantee the right-hand side always must be 0. Remember, it's the level of the C to compare in the table. Okay, now I propose you condensing these two fractions in only one. So to condensing these two fractions in only one, well, I use my algebra. I copy again. Okay. As always, I copy this. But I can see here, okay, 3 is a common factor. Minus 2 over 3. I factor out 3, x minus. This is important because to condensing fraction, I need to find least common denominator, no? Least common denominator. And least common denominator in this case is 3, x minus 3, and x minus 2. There's everything together. In this case, because there are no repetition. And you condense it like that. You copy 3, x minus 3, x minus. It's our least common denominator that allow me condensing this in only one compact fraction. And you divide LCD divided by each denominator one by one, this and this, but one by one. And the answer for this division, you multiply by the corresponding numerator. So when you divide this LCD, let me copy here, 3x minus 3, x minus 2, divided by x minus 2. It's obvious, x minus 2 is cancelled and stay alive, 3x minus 3. Multiplied by 1 is 3, parenthesis x minus. Everyone follow me? Minus, this minus is this minus. When you divide the second denominator, is 3, x minus 3, x minus 2, divided by x minus 3, and 3 is the second denominator. This and this cancel, this and this cancel. Stay alive only x minus 2 times 2 is 2 times x minus 2. Everyone follow me with this algebra?
So far, yes, Professor.
It's good, no? It's elementary, straightforward, no? Okay, now apply distributive property. Boom, boom. Boom, boom. 3x minus 3 minus 2x plus 4. Okay. Entonces es 3x minus 9, ¿no? 9. And you multiply 3 times x, 3x. 3 times 3 is 9. Okay. Over something. I am working only in the numerator part. Entonces 3x minus 2x is 1x. And negative 9 and positive 4 is negative 5. So now my inequality now is in the top is x minus 5 and the bottom is 3 x minus 3 x minus 2 less than or equal to 0. Boom. This is my new inequality I need to solve. Okay, this is equivalent, but this is ugly, not good to see. This is pretty nice. Why is nice? Because right hand side is 0. And you organize the left hand side in only one compact rational expression. Okay, one more detail, sophisticated detail. What do you think about these three? What do you think about these three? I can erase or no?
Yes, sir.
Yes, sir. Why? What is the reason I can? What is the reason I can erase these three? Why? Because it's positive. And the positive, the 3 is always positive number. And any positive number do not participate in the game. Si es negative, no. Si es negative, yes. Pero es positive, I can delete. So this inequality, using 3 or no, it's the same. Nice. Quickly, because we have not too much time. Critical value, what is the critical value in this example? 5 in the top, 3 in the bottom, 2 in the bottom. I do in the partition of the all real number line 0, 1, 2, 3, 4, 5. Select the testing point. I select in my paper 1. I don't know why. 2.5. 4. Why not? And 6. Yeah, I create. Sorry, guys, but I create the table. I want to. In the table, I verification. It only is true in here. Only is true here. Look, let me show you. In the chart, it's true here in 1. That 1 passed the test. And one more guy passed the 4 passed the test. Okay? But the endpoint 2 is no good because 2 is the 0 of the denominator. No. 3 is no good. But 5 fantastic. 5 bracket because it's the 0 of the numerator. So the final answer is negative infinity, comma 2, union, 3, comma 5, bracket. Okay, guys, sorry. The time is over. You know, I would like to continue with you. Okay, but definitely next time we start review. Okay?
Thank you, Professor. You have a great day,
okay,
sir.
Pleasure. Excellent. I enjoy teaching you.
Thanks for the lesson, Professor. Have a nice day.
You too.